All right, so I like to use a real world example of where we're using powers of 10. So the Richter scale, you may have heard of it. Charles Richter in the 1930s came up with a way to measure earthquakes, or the magnitude or the impact of earthquakes. And so in this scale, we have magnitude 1 or 2 or 3, 4, 5, 6, 7, and it goes all the way up to 10. So you may have heard of, an earthquake of magnitude 7, like a 7.0 or 7.5, being a pretty big earthquake, all right? Magnitude 1 is an earthquake that you wouldn't be able to feel. The smallest earthquake that you probably would be able to feel is around magnitude 2, all right? So each one of these magnitudes, 1, 2, 3, 4, 5, and so on, is representing a power, okay? So this is really representing over here, this 1 power. On the x-axis, on the y-axis, we're going to say that is 10 to the first, all right? So if we have a 1 over here on the x-axis, then we're going to, on our y-axis, line it up with 10 to the first power. Again, with 2, a magnitude 2, we're going to line it up with 10 to the second power, all right? And with 10 to the third, which is right here, we're going to line that up as a magnitude 3, okay? So do you see what's going on with this graph? It's not a straight line, okay? It's actually quite a bit curved. This is called an exponential curve. So let's see why it's getting curved so steeply, all right? So if we looked at a question like, how many times larger is a 3.0 magnitude earthquake than a 1.0 magnitude earthquake, you might be saying, oh, well, it looks like it's 3 times as large. You might be tempted to say that, but that wouldn't be true, not even close to true, because remember, we're dealing with powers of the base 10. So in fact, if our magnitude 1 is at a 10 to the first in terms of its power, and then we move up from 10 to the first to 10 to the third, we go from 10 to 1,000, all right? So the Richter scale is comparing earthquakes to each other. So it's comparing, for instance, a magnitude 2 earthquake to a magnitude 1 earthquake. So a magnitude 2 earthquake would be 100, magnitude 2 earthquake would be 100, because that's 10 to the second, and a magnitude 1 would be 10 to the first, or 10, so therefore a magnitude 2 would be 10 times as large, or 10 times as powerful as a magnitude 1. And likewise, a magnitude 3 would be 1,000 on the scale as opposed to just 10. So that's why a magnitude 3 would be 100. It would be 100 times larger than a magnitude 1, not 3 times larger. So do you see that 1,000 divided by 10 is not 3, but it's 100. And so that really shows the power of magnitudes and really the utility of how we can show lots of different scales or magnitudes of earthquakes on the same graph. And in fact, if I were to do a fourth one, it would be about up here. But if we wanted to represent something that was 1,000 times larger, which 10 to the fourth would be over 10 to the first. Do you see that I only have to go maybe up here? That's not that far when I'm trying to come up with something that's 1,000 times greater. So while I would go off of this chart just because I wrote pretty largely here, it's not too bad to just go up to here and say, well, something is 1,000 times greater. There is a lot of utility in using a graph where we can have powers of 10 to show how we are comparing different quantities, in this case, powers of earthquakes.